Ever wanted to drive a lightweight go-kart every day that you can even take the entire family in? Then the Honda Fit, or Jazz as us Aussies call it, is probably the best choice for you. You might be wondering, how can a small hatchback be a practical family car? Two reasons. The fuel tank is moved under the front instead of the rear seats like every other car, and a torsion beam rear end which performance journos often frown upon, and we'll get to why later in the video. These changes alone give approximately twice the storage space with the seats folded up to a Toyota Yaris. In fact, the FN2 Civic Type R, yep, the same one that Jeremy Clarkson clowned on many moons ago, also uses the same platform as the Honda Jazz, which is why it's one of the most practical hatchbacks ever, boasting a staggering 485 litres of cargo space, despite having smaller dimensions than a Toyota GR Corolla, which has less than half the boot space. So I hope you've got a clear picture of the engineering genius behind the Honda Fit, because we're going to conduct an automotive x-ray on the first three generations in particular and dive deeper into what makes this car one of the greatest hatchbacks of our time. Each section of this video has been painstakingly divided into the various mechanical parts of the car, such as the engine, gearbox, dynamics, suspension, and of course, the chassis and underbody. At the end, we'll also touch on the surprising motorsports legacy that such a boring car from the outside can have. But there's only one place to start when it comes to the Honda Fit, and it's the magic seats. For the first time ever, Honda debuted the magic seats, which lent the Fit quite the leg up against even bigger cars when it comes to overall practicality. That torsion beam rear end we talked about earlier actually allows the magic seats to function like a jack of all trades, especially when the utility function. The chief engineer, Kohei Hitomi, said that the magic seats came about after the design team had spent long hours watching people in supermarkets and how they stored their things. So, let's examine what the magic seats can do. Of course, in normal, you can put 5 people including yourself in the Fit. But here's what's sick. In utility, the seat actually lowers onto itself, basically creating a fully flat load surface, giving you heaps more boot space. This is as the torsion beam rear ends, simpler and more compact packaging actually allows for the boot floor to be lower than the multi-link rear ends that other car brands were using in their hot hatches at the time. We also think this is why other car brands have started to use torsion beam rear ends, as despite the limitations in performance driving, car brands realize that the overwhelming demographic of small car buyers just putt around town in a city anyway, so extra boot space is always welcome. Now, if you wanted to store something like a surfboard, Long allows you to do that, as the front passenger seat can fold backwards, and this space can hold items as long as 2.4 meters. And we're not done yet. Say you had to transport a very tall item like a pot plant. Well, tall allows for either the left or right passenger seat to fold up against the rear seat height, and this gives you 1.28 meters of height to play with. Last but not least, Refresh allows the headrest of the front seat to be removed so it becomes a lounge you can relax in, or do other stuff that we won't touch on. And with that, let's discuss the thumping little hearts of the Honda Fit, the engines. There are of course the 1.3 litre engines, making either 82 horsepower in the GT3 or 99 horsepower in the GE8 and GK3. They're 8-valve IDSI intelligent dual and sequential ignition engines and use 2 spark plugs per cylinder, which allow fuel to burn more completely, so you get lower fuel consumption and reduce emissions whilst giving you maximum torque in the mid-range. Well, that's not what we're really here for, except if you're very fuel conscious. Even then, the 1.5 litre is still frugal in its own right. Not only is this engine not available in all markets, but it's kinda boring because it doesn't have VTEC. Now, onto the real thumping heart. We start with the L15A1, which powers the GT3 globally and makes 109 horsepower at 5800 RPM and 143 Nm at 4000 RPM. On Aussie dynos, this typically equates to around 74 horsepower at the front wheels. It's a single overhead cam engine with VTEC, just like many D-series motors. However, it doesn't have any of that VTEC kick from, say, a D60Y8, or more iconically a B18C7 that turned enthusiasts into lifelong Honda fans, the VTEC just kicked in, yo! Effect is due to those multiple camshaft profiles for low and high RPM like the D and B series VTEC motors, and the effect is pretty much called the cam load transition, or famously, the changeover. To clear the confusion, let's examine how the VTEC in the L15A1 works. In the L15A1, a split rocker system allows the engine to operate with one or both intake valves per cylinder depending on load. The second intake valve only partially opens to prevent fuel pooling, which is why you don't notice that VTEC kick. At low RPM, this 12 valve operation results in the leaner air-fuel mixture to improve fuel economy, and VTEC is engaged through all 16 valves, opening at roughly 3000 RPM. Let's talk about the engine design. Like most engines, it uses an aluminum block. In this case, it's a compact 220mm, and it's a heavily undersquare engine with a 73mm bore and 89.4mm stroke, resulting in a 1497cc capacity. The compression ratio is 10.4 to 1, which is relatively normal for a mass market engine. As undersquare engines typically favour low-end torque, you don't quite get that top-end power of the B18C, which is also undersquared, but its compression ratio of 11.1 to 1 gives that B18C a screaming rev limiter of nearly 9000 RPM. With these design choices, Honda doubled down on the relaxed, economical purpose of the L15A1 by using an intake manifold with long runners, allowing an increase in low to mid-range torque. The 43mm exhaust system was made of stainless steel and used an EGR valve. For some interesting tidbits and features that made the L15A1 very unique for a basic economy engine, there's a timing chain to transfer drive, roller rockers to reduce friction in the valve train, a mechanical throttle body, 4 separate exhaust ports, and the fact that the camshaft comes out of the head sideways rather than through the top. Despite this, camshaft removal and installation can still be completed with the engine in the car, adding to the easy to maintain ethos that Honda engines have always had. And just like every great reliable engine, the camshaft uses a timing chain, so you don't have to replace it for a very long time. Let's now move on to the GE8 engine named the L15A7. It's got the same capacity, bore and stroke, and compression ratio, but there are a few significant changes which give the Fitz motor some more zing. Horsepower has now been bumped up to 118 horsepower at 6600 RPM and 145 Nm at 4300 RPM. On the dyno, Aussie-based company Hone Development have tested this engine to make roughly 78 horsepower at the front wheels, 4 horsepower up from the previous gen. But the biggest change between the A1 and the A7 is that the A7 actually uses variable camshaft profiles like the old VTEC motors. So that's why there's videos circulating the interwebs where you can hear the VTEC changeover at roughly 5000 RPM. But it's not a kick you feel like the D or B series, as this two-stage iVTEC system is only on the intake side, with the size of intake valves increased to 28mm and the weight of rocker arms lightened. But if you are looking to make this VTEC changeover sound clearer, we advise with caution, as the L15A7 not only uses a manifold air pressure sensor, but also a mass airflow sensor, which has repercussions if you modify the intake system, such as a wrong air-fuel mixture and check engine lights. Now, on the exhaust side, there are no longer individual ports. Instead, the 4 cylinders merge into one port within the cylinder head. Now, the GK5. Whilst other countries such as Australia got the port-injected L15 Z5 variant, which, aside from a low compression ratio for better fuel economy, is basically the same engine as the L15A7, North America got a completely different beast. For the first time in the Honda Fit's history, a direct injection engine was introduced, and this was dubbed the L15B1. It was the most powerful naturally aspirated Fit engine that was mass produced and sold, and it's a 1.5 litre dual overhead cam iVTEC engine, which features an intake cam using continuously variable cam phasing with a variable lift dual cam low profile, just like the L15A7. The size of the intake valves were increased to 29mm and the exhaust valves were increased to 25mm. A plastic intake manifold was used in, with the same capacity, bore and stroke as the previous two engines. The L15B1 introduced oil jets, a Lightning crankshaft with 4 counterweights, new pistons, and an increased compression ratio of 11.5 to 1. All of these changes meant the GK5 fit now made 130 horsepower at 6,000 RPM and 155 Nm at 4,600 RPM. More power to you, but with direct injection you now have some drawbacks. Drawbacks which you can check out on our carbon build-up guide on our YouTube channel. And with that, let's pivot towards what keeps the engine operating at its best at any speed, and that is the transmission. The gearboxes in the Honda Fit are, well, quite normal. All Honda Fit manual gearboxes are cable operated, unlike cars like the BRZ which use a direct rod linkage to operate the stick shift. Until we get to the 3rd gen, we won't touch on too much about the CVT. Just know that it exists and it's not a common gearbox option around the world. Now, let's start with the GT3. You can get the 1st gen Fit in either a 5-speed manual or 5-speed automatic. Now for the gear ratios. For the manual, you have a very short first gear which helps it get off the line, but the ratios are quite long, especially between 1st and 2nd, so it's not quite the best for performance on the track, unless you change the final drive from a company such as M Factory to make each gear shorter. Now for the auto, the drop off between 1st and 2nd isn't as steep, but 2nd and 3rd are now spaced a bit wider, with 4th and 5th gears being quite tall for the motorway. Moving on to the 2nd gen, which you can get in either a 5-speed manual or 5-speed automatic. That nasty 1st and 2nd transition in the GT3 manual is now much closer in the GE8 manual, with 1st gear being afforded a slightly taller ratio due to the extra 4-wheel horsepower the GE8 now makes, as well as the shorter final drive at 4.62 compared to the GT3's 4.294. It's just an overall closer ratio gearbox. On the other hand, the GE8 automatic gear ratios are basically the same as the previous gen. Now on to the GK5. We now have a 6-speed manual, and when we compare the gear ratios to the GE8's 5-speed manual, the 1st to 2nd transition is essentially identical, but the higher gears are closely spaced now for better refinement during daily driving. Now with the CVT, which was the first time Honda ever introduced a CVT into a Fit, it pretty much continuously adjusts the gear ratios depending on throttle. And while CVTs often get clouded in the car community for the lack of performance and engagement, they're very efficient, which is why Toyota uses CVTs in most of their hybrids. Let's now discuss what makes the Honda Fit or the Honda Jazz such a hoot to drive in the corners: the dynamics. Let's start off with the steering. All 3 Fit generations use electric power rack and pinion steering, but they have slightly different ratios and steering wheel turns lock to lock. The GT3 starts off by using a steering ratio of 12.8 to 1. It requires 2.41 turns lock to lock, and whilst the GE8 keeps the same 2.41 number, the steering ratio is slightly more direct at 12.7 to 1. The GK5 uses a much slower and less direct rack. Our guess is because of refinement on the big American freeways, with a steering ratio of 13.06 to 1, and you now need more steering wheel turns lock to lock at 2.51. And whilst that torsion beam rear is pretty amazing, the Fit, especially the 1st generation, now doesn't have enough rear camber from the factory, and you also have too much rear toe-in. And unless you go with aftermarket shims to get more toe out or more rear negative camber from companies such as Home Developments, you can't adjust your rear alignment as much. Remarkably, despite the weight going up with each generation, the same brake setup is still being used, with ventilated discs at the front which are 10.3 inches and rear drum brakes at the rear which are 7.9 inches. And with the weight going up, you need bigger wheels and tyres to keep it sure-footed on the road. Whilst the GT3 has either 175/65 R14 or 195/55 R15 tyres, the extra weight of the GE8 means the GE8 now uses either 175/65 R15 or 185/55 R16 from the factory. The GK5 uses slightly thinner sidewalls with 185/60 R15 or 185/55 R16. and we suspect that the extra weight the GK5 carries over the GE8 necessitates more grip. Lastly, all fits from the factory use an open dip setup, and when you combine a front wheel drive's tendency to understeer, it's definitely a factory limitation in these cars when you push the limit on track, as the inside wheel pushes you wide mid-corner. Luckily, there's a huge aftermarket for the Jazz, where you can even install limited slip differentials which eliminate this understeer for you. And with that, let's move on to the legs of the Honda Fit or Honda Jazz, the suspension. To start with the commonalities, all Honda Fits use a McPherson strut front suspension and an extended H-shaped torsion beam rear suspension, which you guessed it, allows for a lower boot floor. Each subsequent generation got a thicker front stabilizer bar, with the GT3s being at 21mm, the GE8s being at 22mm, and the GK5s being at a whopping 25.4mm. The reasoning behind this was not just for the weight increase, but to keep the chassis stiffer and the handling more responsive. But let's track back onto why torsion beam rear suspension is commonly frowned upon. As the rear wheels are basically connected by one beam, over the bumps or the cambers in the road, the handling can get a bit unsettled on the limit, especially compared to a multi-link or double wishbone rear setup, where each rear wheel has its own independent movement. When we look at the changes between each generation, the GE8 had a redesigned torsion beam when compared with the GT3, as it was fitted with larger bushings, and it also had a revised spring lever ratio and extended trailing arm lengths for softer ride quality. For the GK5 fit, suspension changes included a new link between the suspension and the front stabilizer bar to reduce friction, and for the rear dampers, a dual path mounting system and blow-off valve. The rear torsion beam suspension was also more compact, with the anti-sway bar now being removed to maximize interior and boot space, with rear legroom increased by 12.2cm and passenger volume increased by 136 litres. That's incredible! With that being said, let's now move on to the final, but arguably crowning aspect of the Honda Fit or Honda Jazz, the chassis and underbody. Sharing Honda's global sport car platform with the City, Airwave, First Gen Mobilio, Freed, and HRV/Vezel, the first generation Jazz was given a rigid unibody design with a low floor that maximized cabin space and cargo capacity, as well as a low center of gravity for better handling. With the GE8 comes a significant difference. The chassis was re-engineered for the second gen Honda Fit, with structural rigidity increasing by a whopping 164%. That's outrageous. And the GK5? It's even stiffer than the already stiff GE8, as it ended up using Honda's all-new global small car platform, which used ultra high strength steel, which was 780 MPa of yield for 27% of the bodywork. In the GK5 Fit, the body panels are both welded and bolted to the frame in a hybrid monocog and space frame fusion. Funny enough, the second gen HRV actually uses the same platform as the GK5 Honda Jazz. With all the engineering analysis out of the way, let's now move on to the quirky but interesting motorsports legacy the Honda Fit is slowly cultivating amongst track day enthusiasts. When it comes to straight line performance, 0 to 60 miles an hour or 100 kilometers will take you roughly 2 to 3 business days. But on a serious note, straight line speed was never really the Honda Fit's forte. It's become an incredibly tempting seat time car, simply because you can run cheap small tyres that last track day after track day. The L-Series engines are easy to work on and take a serious beating, and the Fit, or Jazz as us Aussies call it, is an incredibly cheap car to own and buy. In fact, Grid Life hosts the Sunday Cup, a series of time attack racing inspired by the previous Spec Fit series. The motoring lore dives deeper. As of 2010, you can actually use the L15A7 in the GE8 Honda Fit for SCCA sanctioned Formula F competition, and when it's the end of the road for most other cars, it certainly isn't for the Honda Jazz. In the 2012 Australian Rally Championship, a second gen GE8 will take home first place for the two-wheel drive cars, and in the 2019 100 acre Wood Rally, a third gen GK5 would also take home first place in the regional limited two-wheel drive class. That's a seriously impressive motorsport CV from such an economical and little city car. Let's now head into the concluding remarks. Overall, what are my thoughts on the Honda Fit/Jazz? As a massive Honda engine fanboy, it's got to be my favourite economy hatchback ever. This car really brings out that fun go-kart character the older EG and EK Civics had, whilst having a much stiffer chassis and being much safer out on the open road, all in a package that's shockingly spacious and practical despite weighing just over a ton. And when you combine its reliability and dirt cheap asking price, it is really so much car for your money. And dare I say it, as much car as you'll ever need. If you've got any other cars you want us to conduct an automotive x-ray on, let us know in the comments. Thank you so much for the support already with the previous automotive x-rays. Let's keep this up so we can continue to make this a regular thing on YouTube, where we really break down and dissect some of the best cars ever. Much love to you all, and I'll see you in a bit.